monsoon. We started in 2015, and so it was amazing. It here. And the first year, what forecast drought. Okay, and in the first 2 months, it looked like they were wrong. Okay, but things changed rapidly in the last 2 months, and now did occur. And so this year, also not only by IMD, but almost every forecast center, but still one cannot be 100% sure because one cannot depend only on El Nino, although it's a major factor to determine what will happen. You will see that there are many other factors there. So although the probability of drought is very high, but it is not. So this is the status today at 12:30. You can see that there is a rainfall system right close to this one. There's a model forecast from Zoom. It looks a little attractive to put it there. So what you want to notice is that the IISc here. I think that is it. The IISc here is already around 15 knots. Okay. Here, this is the delay part. And this is the interesting issue here that you all talk about onset of monsoon over Kerala. But before that, there was the onset over Bay of Bengal, then over East China, where it has already gone, and then this comes. But I have not seen any paper linking the three, because there's a sequence. It does happen in the sequence. So I think I want to ask you, has anybody linked the onset of the Chinese South China monsoon with Indian monsoon? Yeah. So there has to be some link because there's a sequence in which the thing happens. Okay, so as I will show later, the Indian monsoon onset over Kerala was supposed to be on May 26th. It did not happen. And now they're saying June 4th, tomorrow. I'm still not sure because, yeah, there's a hint of rainfall system close to the Kerala coast, but for a long time, the system was hovering here, but didn't touch Kerala. Okay. So how do I move from there? Okay. Yeah, so this is day after tomorrow, 5th June. You can see that this is a clear to me, if this body is right, of the onset of Kerala, because this, the color was in the previous picture, but this is really high. This is all not very high rain. The rest of the coast are seeing this heavy rain. So this model says 5th June, it may even be 4th. Okay, so in the last 1 month since I have made the forecast and I've made the forecast, there's a whole media hype over a super El Nino. Okay, there's a lot of talk about it, what's going to happen, so on. And so there's a nice comment I saw. It says, it is too early to forecast. That's correct. We are only in June. But not too soon to prepare. Because if it happens, we're in trouble. Now, because of the super El Nino forecast, our media needs things exciting and keep you engaged in social media. So we are talking about major drought comparable to 1877. Okay, 150 years back. Now, why is that? Because in the 19th century, there were a large number of droughts in India, one after another, from the 1875, and that's why they established IMD. Okay? And had a huge impact on India into the deaths and famines. Now, if you want to know about it, it's an amazing book written by Mike Davis. I recommend it. I have a copy if you want to take it. It's a very big book. It takes months to read that. So, he points out that the famine that occurred in India and other parts of Asia is not just El Nino. El Nino was a trigger. The real thing was exploitation of these countries by the British. With the British Empire, they used India as a source for agriculture and was exported to England. Okay. So there are all kinds of, it's a very depressing book. You may not like it, but it should be read because you must understand history as to how the third world was created. talks about how the survival is made by outright exploitation of the agriculture in not only India but other countries. The Australian brutal famine. This famine is not due to El Niño alone, due to man-made causes. Now, this is the present state. Today that I don't have. Today, just now today. So it has gone up to 6 millimeter. 3.4 estimate today it is 6 millimeter per day. Still, it's below normal. Okay, so it's very early days. We have to watch how this thing develops. Now, if you look at the rainfall anomaly, it looks quite nice and uniform, but it's very small, few millimeters per day, 4-5 millimeters per day, all across India. So these are all pre-monsoon thunderstorms in North India. And if you look at what the forecast made for May, June, July, it is already in April, March yesterday. CFS multimodal already indicated that May, June, July will be below normal, although April, May, June above normal, clearly showing June is the month where things are going to be bad. But what surprises me, you'll see later, that the forecast for June by IMD is 8% below normal. I think they are wrong. It's going to be much worse. The way things are going. Okay, I'll just summarize the last 10 years of monsoon discussion. What I want you to remember is that we had 44 months of data here. Okay, only 1, 2, 3, 4, 5, 6 months were below normal. So we had a very nice period of only one drought, 1 year drought. Okay. So all the others were normal or well above normal. Now, why is that? This is an interesting issue. I told you 2015, El Nino, IMD forecast a drought. It was a drought, and their forecast was good, not only for El Nino, because PDO was positive. That's what some of people don't pay enough attention to, because PDO has a very similar temporal pattern as El Nino, except that it's a much longer period, 10, 20 years. And but it plays a role. As a matter of fact, one of the books of Arindam shows how the SHA anomaly in the North Pacific around 2030 knot plays a role. Okay? But next year, after the success, I'm very confident. So next year, La Niña came and they said it will be a flood year. But they were wrong. Why? Because they forgot to take into account this. This is going against this. So here, El Nino gives a personal model video, these two add up, these two subtract. So that plays a role somehow. Only recently I saw a paper, which I will discuss, where you show that you have to look at both El Nino and PDO. There are, both are positive, you have very heavy drought, both are negative, you get very heavy flood, but in between you're in trouble because they act against each other. And the luck was, in the last 5 years, this was always negative. Okay. And there was 2 La Niñas. There was a weak El Nino, which did reduce the rainfall, but not as much as this. Okay. So you can see that 2015 and 2023, both El Nino years, the difference was PDO negative. Okay. So to me, this is something that has not been given some attention. Someone in India is more focused on IOD. I'm not in favor of it because IOD really picks up after the monsoon starts. Okay, so there's no any predictive value. It goes along with monsoon. So IOD as a predictor is to me a very low value, but PDO is a much longer term phenomenon, 10, 20, 30 years. So it has some predictive value. Okay, so this, those of you who don't know, this is the positive case of PDO, looks like El Nino, but extends all the way up to 60 knot. This is the negative PDO, looks like La Niña, but extends all the way to 60 knot. Okay. So this is a statement made in the paper I quote. When ENSO and PDO phases align over the El Nino events, or negative phase align, anomalies are amplified. That's the whole point. And I think data understanding supports that view that we should have a co-calculate video. Okay, the only trouble why people don't like video is video and El Nino look very close to each other. Look at the time series. Okay, you can hardly differentiate between the blue line and the red line. They go together. Okay, but if you look carefully, you will see there are years like here and like here, entry positive, and here only a few years. Okay, where because video has a much longer time period than El Nino, when El Nino changes, video doesn't change automatically. Okay? So there is a little lag. So if you look carefully, and in this paper I'm going to mention, they looked at all this data. They went up to from 1901 to 2000. Although I'm a little worried about the reliability of SSD data before the satellite data. I don't know how good it is, but you have no other choice, but people use that. Okay. So this is the data which was used in this paper. Now, what they did was they plot the video index versus El Nino index. Okay. Now you can see most of them fall on these two, both positive, both negative. Okay. That is expected. But there are enough points of this side and this side. Okay. Whether they are statistically large, I don't know, but there are points there to look at. Okay. So to me, I would have thought since most of the points are here, this, but if you take a long enough time series, then these two will show some signal. Okay, so this is the from Anupam Xavier et al. Published about 3 years back in climate dynamics. So what they're pointing out is that if both are negative, you get a, this is SST anomaly. You get a strong SST hit anomaly. If both are positive, El Nino and video positive, you get this. But in between, here, because of negative video, this is weakened. Here, because of positive video, this is weakened. So that is the message they're giving. Looks quite good. But my only doubt is that the quality of the SST data before 1970, and but that's all we have looked at. But somebody should look at this with coupled ocean quality model, which have been integrated for 100 years. You can examine that in the model, how much does it do? Still more data. Okay. So in the period they are examined, they got what they call pure positive video, that is ENSO neutral, 14 years. Pure negative video, ENSO neutral, 11 years. Pure El Nino and video 0. And then video neutral. So they got about 25 plus, yeah, about 50 years. Okay? Which in a 100-year data set, I was surprised, but they had it. So, and what they are showing here is estimate distribution. Okay, the same. Now, you look at the PD over the last 10 years, you can see it was positive for 2 years, which had impact. Then it's all negative till this year. Okay. It is somewhat weaker this year. I don't know what's going to happen. It is not as strong as here. So it is slightly weaker, so it might flip sometime. We don't know when. So whether this year negative video will somewhat dampen the effect of ENSO is something we still don't know. Okay, now what's the prediction of video as far as CFS V2 is concerned? They are saying that it will continue to be negative, but it's more than not that accurate for video purposes. But at least till Jan 24, they are saying it will remain negative. Okay. Now let's look at ENSO. ENSO this year, 30% reached almost 0.7, right? And rapidly going up. So this is very similar to many years we started as a La Niña in January and went El Nino, the same slope. So that's not a good news. And one problem now in this field is that when you talk about El Nino, we can assume that we calculate anomaly near 3.4 based on some long-term average. That's a normal practice, right? That practice is in trouble because of global warming. Okay? So now what I do something by shifting the climatology closer to the present, but people didn't like it. Finally, there is a new concept called relative. And in a way, look at the actual temperature compared to 1856. Today, the temperature is gone up by 1 degree. Okay. So that's just global warming. So that is not going to affect the ENSO phenomena because ENSO phenomena is driven by temperature difference between 3.4 and all the other regions, right? So you have to get rid of the global warming signal. So the present practice is to calculate the 3.4 SSC, subtract the tropical mean SSC out. Okay? So when you look at all the data, be careful, find out are you talking about the old 3-point index or a relative index. There's a difference of about half a degree, 1 degree. Okay, so this is the statement which was there earlier. Now they are removing this tropical SSC out. For the relative, Okay, now let's look at what happened in 2014-15. 2014 was supposed to become El Nino, but it essentially aborted in the sector below 0.5. But then in 25, January, February, March, April, May, you can see it was 1 degree in May. Okay. Now this year is 0.7. So we are going to say particle survey because this is the water, warm water volume in the equatorial Pacific. It is highly positive. So a lot of heat is there. It's all going to come out. So we are going to see a similar rise. Okay. But what is critical to us is the rate of rise. If it rises slowly, then by the time September comes, it may not go much beyond 1.5 or so. We are lucky. But if it rises rapidly, as it did here, you're in trouble. So that is the critical thing to see. At what point El Nino will begin to impact the July or the August winter? Remember that Indian monsoon, June is really not that relevant. What's relevant is July, August, September. Okay? Even June is below normal. It is over the next 3 months. It will happen in the past. So the issue is in July, August, September, what will be the Nino 6.4, which may have an impact on the monsoon. Okay, now this year you can see that in 2024, we came out of El Nino in 23, rapidly went down because of the negative warm water volume anomaly, went all the way to La Niña in 25 and hovered around that. And ultimately, in 2026, January came out positive anomaly and then started rising. Now it's going to, I'll show you the next few months, it goes like that. Okay. Now, how it goes up with the issue? That is the main challenge.
But yes,
Yeah.
in 2025,
Ah.
that volume of groundwater compared to 2015 has already arrived early. So don't you think that would make that would better?
But
If you look at the numbers, if you look at the
yeah,
numbers,
it's larger. Yes.
the number is already arrived.
Yeah. That's correct. Good point. I could have put it up. Good point. If you compare 2020 before, the most worrying part is, I'm sorry. Look at this number is 1.5 to the power of 14. Okay. Look at this. This is 3. Yeah, it's double. So you're right. It's not really a huge issue. All it really comes out. Question: how could it come out? You are the best person to answer. This additional heat anomaly is there. Is it the weight on the surface or what factor will make it come out quickly? That is the issue, right? That is where. But point is almost all the models are predicting rapid rise. I'll give you a few examples from various models. So it was, I want to point out that minus 0.5 in March, April, right? From there, Here it has come to plus 0.7. So it's going up rapidly because of the high positive environment. Okay, I want to show you this referring to what Vinay asked. Last year, the forecast that was made by Srinivasan B2 about how SSP will evolve in 19.4 was very poor. This is actual data. Only one, which one I think April 21st shows some connection. All of them were showing warming. So there's a problem with the model. Models are not able to correctly predict the short-term evolution of the SST. So although I showed the results, but remember, the results are sensitive to the model. Now, the other one complication that has occurred in the last 20 years is in the period 1980 to 2000, really, the peak in the spectra was around 48 months, 4 years, what is there in textbooks. But in the last 23 years, we have a peak around 20 months. That's very peculiar. I don't know what such to make out of this data, because it's short period data. So there is some difference in the way El Niño is behaving in the past to present. This may be related to global warming or maybe something else. Okay? So this is a very unusual result. I really find it surprising. Somebody can verify whether this analysis is true, maybe that's something else. There. Now let's look at all the years which went from La Niña to El Niño. Now this is based on Aringham's work, and Aringham has shown that they go El Niño to La Niña, 90% of the time you would have a drought. And then 1 year, that is 1925, which was normal year. We don't know why. I don't know whether anybody has looked at it. It was not peculiar, but that is this one. In 1925, okay? It was negative till May, and then rapidly rose. So we are following, unfortunately, 1972, which is very bad news. 1972 was one of the worst droughts in the last 50 years. So if this is the direction it's going, we are not going to be in good shape. Okay, now let's look at some European Centre forecast. So March, April, May is here. They are forecast around 0.7, which is correct. And they are showing June, July, August, we go to 1.5. Okay. So that is the forecast of ECWWF. And 1.5 by itself is not worrying because our other model saying is go to 2, which is much more serious. Now, this is, I think, I forget now which model is that. This is relatively new 3.4. I think this is Australian model, if I remember correctly. What I want to show you is the difference between two initial conditions. Okay. April 1 shows 2, and May initially already shows about 2. Okay. So it is sensitive to the initial condition that is used. So, if you go by this model, it will go to about 2. Now, let's look at the forecast by NCMRW. It is, I think, it is too high because they are showing this based on May, although they don't got the point yet. But in June, they say 1.5, but I doubt it will be 1.5. And in August, September, they say 2.5. Okay, that is really bad news. I hope it's not true. Now, this is NOAA people are doing a different way, more probabilistic. That to me is more realistic. Now, what you see is that, let's say July, August, September, which is the key for the Indian monsoon, there is only 10% chance that it will be above 2. That's good news. Unfortunately, there is 40% chance that it is above 1.5 and 30% chance it is above 1. So 70% chance is above 1 and 1.5. So that's sort of El Niño. As a matter of the first time I'm seeing El Niño forecast in May saying 100% in the coming months. Not 70, not 80. El Niño is guaranteed to come. There's no doubt about it. Okay. Now, one thing I saw which I thought students should know, although we all focus on anomaly, which peaks in December, the actual SST in the Pacific peaks in May. The climatological variations in May, remember that. So don't get too influenced by the anomaly, but the seasonal cycle obviously has to maximize in summer and then does go down. So this is the replacement cycle. This is anomaly in 2016. And you can say anomaly is very large because the seasonal cycle should be cooling down. It's cooling down, it's moving up. Okay. So this is a point worth remembering. And you look at actual resistance on our book. Now, this is a paper from Arindam where you show that if you have not El Nino in summer, then you're 9 years and only 1 hour you're 8 drought years. Just going by climatology, no prediction and no other sun. Just saying that based on the past data, you are guaranteed to have a drought. Okay. And he's saying 99.7%. Okay. But that is provided, I think you analyze after 2012, right? 2014, something like that. But in the last 12 years, warming has accelerated, global warming. So we don't know what the consequence of that is. Okay, now this is a graph showing all the possibilities that Arindam highlighted. We are looking at this one, going from La Niña to El Nino. Okay. Now, in that, this is the average. So you can see that in May, average transition is around 0.3. We are already at 0.7. Bad news. In June, it is close to 0.4. We'll probably cross 1. So this is what we'll keep in touch and see. If this goes much faster than this, then we're in trouble. Okay. Now, let's look at a few other things here, which is quite complicated matters. One is, Arabian Sea is very warm. Okay. This Arabian Sea is warm with a lot of water vapor. Now, the conventional view, which I don't agree with, is that El Nino causes a decline in circulation. Okay. That's only an association. They don't have any mechanism for that. Because it causes a reduction in circulation, these winds here go down. But the temperature is still high because of global warming. And my view is that the two may cancel out. Let's hope that's true. That is, in the last 30 years, the warming is around 0.5 to 1 degree. And all of you know that water vapor amount increases 7% per degree centigrade. So 7% increase in the specific humidity may balance out a 7% decline in total wind. That is expectation. That's one part. Okay. The other part is what is happening in the Pacific. This is what Arindam focused on in one of his papers published in Monsoon, that this region is equally important. It's also very warm. Okay. So that also has impact. Actually, in this paper, he has shown its impact on June, July. And I was really impressed because the correlation was 0.9. I never seen it in any statistical analysis that the correlation between SST index and rainfall is like 0.9. We know 0.6, maybe 0.9 is remarkable, but I think after that it was not that good, right? After you published it, things went down. Yeah, that's all. There are complications in this problem, but I think we have to keep impact of what that will do to the Indian market. But what is usually allowed to say based on May data? Maybe next time we'll tell us what we see. Okay. So this is another complication, Atlantic Ocean. It's quite warm. This also has the effect of monsoon. Okay. So by just taking the El Nino monsoon connection, we are ignoring global warming. We are ignoring the role of Arabian Sea. We are ignoring the role of North Pacific. So all these might be lucky contracts. Okay, now here is an example. If the Atlantic is very warm in this paper by Yadav, then we will be lucky in South India. Okay? Rainfall will be higher. Okay? And but this region, Central India may still be bad. but both South India and the Himalayan foothills and Northeast may gain. Okay. So this is the role of Atlantic Ocean. Now, they have shown this by looking at June to August. Cold Atlantic minus warm Atlantic is the opposite of what we saw last second. So Atlantic is cold, there will be higher rainfall in Southern India, lower in South India. But now I think it's the other way around, so it might flip. Okay. And this is in millimeter per month. It's not much, about 30 millimeters, but I can tell you that makes a difference between 80 United States and normal monsoon. Take 10% there, around 88. So you come close to 800. Add a few 30 millimeters, you escape drought. You still be below normal, but you will not have drought. That happened in a few years and so on. Both 2050 days. Okay. The other important point to remember is that the tropical Indian Ocean, both north and south, it's assessed in response to Niño 3.4. Right? With a delay of about 3-4 months. So in the next 6 months, you will see Northern India warming up. And how quickly it warms up is going to be an issue. If it warms up quickly, then it will affect us. If it warms very slowly and only after September, it has no benefit to us. Okay. So this is what Yang mentions. And what he makes like very much is IOB affects the summer monsoon and IOD affects the winter monsoon. So that's why the Chinese scientists are very keen on IOD, because it happens later in the monsoon season and affects the winter monsoon of East Asia. A lot of papers are published on linking the IOD to the Chinese monsoon. Okay, so I didn't want to highlight this important point because not sufficiently highlighted. If you do an year of the SST in the Indian Ocean, highest variance is the basin mode. That is 20 south, 20 north, whole of the Indian Ocean. IOD, about which so much is talked about in India, has only 10%. And it peaks later in the season. So to me, the focus of IOB, not IOD, there's also IOD triple. I think that's about 7%. I think it's not publishing. I don't think it's going to have any impact on your prediction. Okay, so just to highlight what it does, here is a paper by Zheng Peng Zhou, who first looks at only effect of Niño 3.4 and only effect of NIO. And I want to know that North Indian Ocean, okay, has an impact later in the season. Okay. Early in the season, actually, it causes, in June, it causes the drought. Okay? But July, August, September, it makes it better. But Niño 3.4, of course, gets worse and worse, and September is the highest impact. So this year, if you are going to have a serious drought, it will be because of September's failure. Okay, so how is the dipole going? It is right now close to 0. But I don't think one can trust this forecast. It's all over the place. Okay? So it's not going to be highly positive, even by September. So this is CFSV2 forecast. And this is the NC model forecast. It's going to lower. Look at the variance. So it's no use. There's huge variability. Now, remember last year, we had an unusual year. We had a large number of weather disturbances, which fundamentally altered our understanding of summer monsoon. So that is another surprise element. If, like last year, this year also, is coming to India, then the drought prediction may go wrong. Okay? But we don't know. Nobody has understood why last year there's so many weather disturbances one after another. And Hunt has published, I discussed these papers last year, but still I don't think there's an understanding as to why. He says global warming could be one reason. Because of that, he thinks these disturbances interrupt monsoon. if it happens this year, then all the statistical then forecast based on past data are going to be wrong. So you can see that in spite of the fact that we know El Nino has an impact on the monsoon, so many other factors are also playing a role, and that might alter the story totally. Okay, now I come to a very controversial statement, which I like, many people won't like it. I believe that there is not El Nino, which is Indian monsoon, but the Indian monsoon affects El Nino. Okay? So this we discussed over the last 5 years, how one can, when you have two time series, it's not easy to say which is causing which. So there's a so-called granted equal statement. So there's a recent paper which I like by Susan Lee, who argue that the Indian monsoon increases the easterly wind over the Pacific Ocean and leads to a La Nina. The Indian monsoon is strong this year, the El Nino cannot grow. But if the Indian monsoon is weak, El Nino will definitely grow. So this is a challenge. So the point is that traditional view is El Nino causes the monsoon. Right? The more, what you call, radical view is monsoon affects El Nino. But as you know, reality is in between. It is an interacting system between ocean and atmosphere. Both play a role. And as Melander made a famous statement in his book, they are two words dancing together. Both are affecting each other. There's no clear A causing B or B causing A. A and B are mutually interacting. So that's a problem. But this is you were looking at because this is different. The aim of this person was not Indian monsoon. Okay, he's not in India, he's in China. He wanted to know how Indian monsoon affects DJF, 3.4. Somehow nobody has done. I'm surprised. Nobody asked this question. What is the correlation between? People have done the correlation, but didn't ask the mechanism. We have discussed this. We have shown that the September rainfall has a strong correlation with before than June, for example. We know that. But the mechanism is not. This man has looked at the mechanism. Okay. So please look at this paper. And he does a very interesting analysis. He plots in the observation, and also the model also. In the observation, years when Indian monsoon was dry, El Nino developed rapidly. Red line. Years when Indian monsoon was very wet, it did not develop. To me, there's a beautiful result. But again, there's a problem with sample size. One can argue about it. Talk restrictions because sample size is not large. When I talk about El Nino, La Nina, in a 50-year period, you get 10, 12 samples. It's a bit tough. But to me, it's very clear. Look at this result. When there is no El Nino phenomena, if the Indian monsoon is weak, a slight warming, but look at the number. This is 0.2. This is 1. Huge difference. Okay? So to me, again, La Nina can say La Nina becomes stronger and Indian monsoon is stronger. So to me, this is a very interesting viewpoint, an alternate viewpoint which should be looked at critically because there's been too much belief in El Nino affecting the monsoon. Okay? Now, let me come to further. From the last 40 years, I've watched very simple argument that because of the shift in the rainfall system from west to Central East Pacific, the circulation, that anomaly in the Walker cycle, which caused anomaly in the Hadley cycle. I don't know why, but this is the belief that in all the papers published, there is no basis for it. It's all nice cartoons being drawn. There is no rigorous analysis which shows that Walker cycle has indeed changed because of 3.4, and that further changes the Hadley cycle. It's all post-factor. So, for example, to say that in an El Nino year, Indian monsoon, there is a anomalous sinking motion is correct because Indian monsoon is failed. But the cause may not be El Nino. Another monsoon fails, of course, there is no sinking motion. It's a consequence, not a cause. Okay, but this is completely mixed up by everyone. Okay, here's a typical cartoon for one of the papers. I believe there is no rigorous scientific basis for drawing these nice contours. There's no basis. And Srinivasan to say that these are rangolis. People draw rangolis happily. It has no basis. Okay, there's more rangoli here. You can see very complicated language. These are all beautiful, looks nice. But if you ask, where is the actual data to support this relation between circulation and acidity? The answer is variability. Okay. So that's the problem we have. Because I'm not saying this just to make fun of others. It is a problem with the covered system. It's not easy to separate out the cause and the effect. Okay? And the reason I'm saying this, the best way to do it is through a model, not observation. Observation is very messy. Things are hopelessly covered. But in a model, you can artificially suppress. Okay? People have done it, but some of them don't want to have it. Now, I want to highlight my favorite author, Neelan, one of the most creative scientists in tropical meteorology, who argued, and this paper is not cited because I'm surprised. It was published in 2022, 24 years ago. Okay? He took an AGCM, put a Niño 3.4 anomaly only in the Pacific. Rest of it was climatology, and there was no air sitting over this Pacific. So the argument that Niño 3.4 anomaly was air the rise over East Pacific and sink over East Pacific is fiction. But it's there in the public literature everywhere. And I don't know why nobody challenged it. Okay? The point he has made very nicely, GCM do better at predicting increased rainfall and response to acidity forcing than simulating exact location and intensity of descent zone. That's the example. So what he's showing the paper is, if acidity over West Pacific, it is due to local causes, not due to Niño 3.4. Something locally happening due to energy budget, cooling of the West Pacific locally is affecting not East Pacific. So this is a very important paper. Please read it. And I'm surprised that enough people have not looked at it at all. Okay, now why is it? Because Indo-Pacific bomb pool is the biggest pool in the world. It has an impact on global climate, not this region. This region is okay for El Niño, La Niña is very important. But otherwise, the Earth's climate is dominated by what is happening here. Okay? And people are not studying it sufficiently. I remember I attended by chance a talk by Jerry Field in 1991, long time back. And he did something very crazy. He was doing global warming, not El Niño. He, in his NCAR model, he increased the albedo of the clouds in the region. That's all. No other part of the world. Only on the warm pool of the Pacific, he changed albedo. It brought down the global wind capacity. Now, nobody believed it. There was a big commotion in the audience. There were about 200 people in the audience. They couldn't believe it. But no, in 1993, he did not integrate this model long enough. There were question marks about that. But it is published now, although it is not cited, unfortunately. This is a very important point, remember, that your model performance depends upon what the albedo of a cloud in this region, how deep it is, and your cumulus scheme, all that is going to affect that. And that is not understood sufficiently by people. And that's why no two models agree on the impact of El Niño, because this is where the model has to focus on. Now, here also people draw a simple power circulation, okay, around the warm pole. But this is irrelevant. I was thrilled to see a paper published a few years ago, following my favorite Lagrangian method. Okay, Euler is nice. That's where you solve equations, but it tells you nothing. So this paper, published by Dana Reiter, is very interesting. Please follow that. And I want many of you to use that method. She looked at the rising motion over the warm pole by following the trajectory. It doesn't sink over, it goes like that, goes the southern hemisphere, goes on the jet and sits over South America. Okay. This is completely shocking, okay? This is not what people tell us. And I asked her, have you looked at 3.4? She said, no, she did not understand that. But somebody has to look at 3.4. Just look at the trajectory of the particles. Very simple. It's easily available. There are software available for it. Find out whether the air rising during the 3.4, where is it sinking? It's not sinking here, it's sinking somewhere else. Actually, this is a very fundamental problem in atmospheric science. This has not been addressed sufficiently. So, when air rises, it need not go along longitude, it can go along latitude. So, I've not seen a fundamental paper telling me if the air is rising in a particular latitude, what fraction will go north-south, what will go east-west. To me, some principle has to be there, right? But nobody has talked about it. I may have missed it, because literature now is very vast. And if you see anyone clearly initiate a principle, it tells you of 1 kg per second air rising. What fraction goes this way, what goes this way? To me, that is very fundamental understanding of what's happening, but I'm not sure any paper talk about it. Okay. So this is very interesting as well. And we are looking at the tropical runway belt, similar to ocean. Also, yeah.
I have a question here, but all that people have described about this ascent and descent is based on oil or data.
No, that is consequence. You're right. I also think I show you all that. Overall, obviously, high over it. But
About Indonesia, that's why Indonesia.
no, but the question if the overall of the change due to this, what is something? But but
So I'm saying is that oil is data, just like
yes,
pictures are based on
here. Now, just what is the fact? That's what you're right. What is the suspicious? What you're right. What Neelan found in his paper is based on his model. It may be wrong. Absolutely right. Somebody has to repeat that and check that it is not model dependent. But you have made the right point. I want all of you keep it OLR. OLR is the best place to understand what's happening, but cannot explain the causes. Okay. Now we'll come to this year's onset. Now, I'm always surprised me why people worry about onset so much. So all of us know the date of the onset of Kerala has nothing to do with seasonal rainfall, no connection. But still, media is observed. There's a reason for it. We are a country where in most parts of India, except Bangalore, there are only 4 heavy months and 8 dry months. So most of North India, both farmers and people in cities, there's water shortage. They're desperately waiting for the first rainfall of monsoon. It's absolutely crucial. So that's why this person in one of the papers identified various issues related to hydrology, related to farming, related to heat waves. They're all connected to onset. Okay, so onset is important for a society, not because of a seasonal rainfall, because it affects what happens in June and July. Okay. Now, of course, this is the well-known graph showing how we do a compare many years data. First, the climate topic changes, right? And it's related to humidity change around Kerala. Okay. Now, I have to use the 6 predictors using a statistical model to predict onset, and they claimed that in the 21 years from 2005 to 2025, they were correct except 2015. Now it happened more. This year they were wrong. Okay. So this is a problem with statistical model. If there is global warming, if there's something else going on, your statistics can go wrong. Arindam has an alternate, but he's not published it. I don't know why. Arindam has an interesting onset theory based on surface pressure, right? That's the main criteria, which is physically more meaningful. But I don't know why he's not publishing it. I hope you published it. Actually, I hope you present it here. And the problem that Arindam has is that his onset will be based on ERFI data, right? Not IMD has its own way of defining onset. So you can show us, because your method is superior. You said this year, the 2nd June, it may happen tomorrow, so you're right. So I suggest that you present it here one of these days and publish a short thing. It may not be a long one because you have limited data. I think it is superior to this method. Okay, this method worked well for 25 years. So this is the point I have not seen sufficient discussion in India. Chinese are very much concerned about the 3 onsets, but some in India not there. Okay, so they did 20% of 4 days. It's gone. Today is 3rd June. So they are saying tomorrow. I hope they are right. And if they are right, then Arindam's forecast will be within his error zone. Your error zone is 4 days, right? Yeah. Okay, so right now we are hovering over the tip of India. I've been watching the satellite data. It's amazing how the ITCT or Sri Lanka is beautifully there for around 1 month. Okay? But somehow it's not progressing. So we're not sure why it is stagnating. It is, how we can see here, over a 15-day period, the ITCT was around Sri Lanka. So that is the thing which we still don't fully understand. And one of the reasons is, of course, the MJO. All of you know about MJO. You can see this is the MJO-based overall anomaly, which when I talked about. So there's a large overall anomaly, watch anomaly of the order of 30 watts of it's very large during June 1st. And next 4 days, still there, stronger. Next, about say 7 days later, even out is there, it's going to disappear around 10th of June. So this is having an effect on the onset. Okay? So that is one possibility. And this is the MGO forecast made by GFS. You can see it is somewhere here, not the region, and it's going to weaken. As a matter of fact, one of the things about MGO is when the Indian monsoon onset occurs, MGO becomes weak and becomes irrelevant in the subsequent period. So this is going to go somewhere here. This is the unit circle. Once it goes below this, MGO is not strong, but it was quite strong in early May. In April and May, and in June it was quite strong. It was in the sector where it is not good for the Indian monsoon.
Yes, it's not good for the Indian sector.
Yes,
for a long time.
yeah. You're talking loudly. Have a hearing aid on. Yeah.
Okay. Go back by your MGO forecast. I think of longer have an onset thing.
Yeah.
We take longer than what they are predicting right now as 4. So it could be more like 10 or even
Yeah. That's not good stuff. But again, it's a very fine. Whatever causes the onset effect is going on. It not over the thing. So what? So it's the basic not if that's the word.
I that
Point whether the monsoon is developing something rapidly to kill the MGO. Okay, so this is a different phase of MGO, and right now we are in phase 7. That's why the problem is. right here. Okay, and as Ravi pointed out, there are two more phases to cross before things become favorable. So it may be delayed further. Now let's look at the actual forecast by the IMD. The week from 29th May to 4th June, they are predicting positive year, negative year, because monsoon also has not occurred. So this is a short-term forecast based on 28th May. Okay. Now this is a little misleading. Although nice to show percentage deviation, but you know when in the month of May rainfall is so low, you get a high percentage deviation than anything. Okay. So I want to show the actual value so that you appreciate it. The actual value is not much, about 4 or 5 millimeters per day here, and actually larger over Kerala, but it's not enough to have an answer. So it's raining here, and there is nothing in between. Now comes the next period, the current period. It is 5th to 11th. Okay, and you can see it's not good news according to the forecast that most of this region will be below normal, and this whatever system is here is not part of monsoon. Is continuously.
Is there a western disturbance? Is there a western disturbance coming?
Yeah.
That's what it looks like.
Yeah. Now, this is the same thing shown in the 4-week forecast. For those of you who followed this discussion, you know that only the first 2 weeks are reliable. This is the 3rd week. It shows answer. We don't know how correct. Okay? But the bad news is the 4th week already is a negative anomaly of rainfall. So it's not going to move further. Kerala answer is okay for those who have been Kerala. But for those who stay in North India, they are worried about when it's come there. I've been there, I can tell you, June is such a bad month in Delhi, Kanpur, and so on. There are a few thunderstorms, increased humidity, temperature is high, it's almost unlivable. Okay. Okay, this is the estimate audio. It's amazing. It agrees with IMD. It is going to be bad this week. But this is much worse than IMD. All the 3 consecutive peak periods are below normal.
Yeah.
So IMD and don't agree about this 3rd week, but we know that not that accurate 3rd week. Okay, that comes the final part, which is the seasonal forecast. Now I want to tell a little story for those of you who are young and don't know. For a long time, based on the tradition, Dr. Walker 100 years ago, he did seasonal forecast based on statistics. Now, there's an interesting story behind it. There was a person called Novaricus, who was secretary of DST. He made the seasonal forecast using a large number of predictors when we have such a small numbers. Okay? It is statistically not correct. Okay? But he was secretary of DST. Whatever he said is the truth. Okay? So he made this forecast, and he was lucky. First year, they made a qualitative forecast. That's okay. That's a good year. Next, so many years, their forecast and the excellent was within the error bar, which is usually 6%.
Yes, something if I look at 94, what 94 he predicted was 92% almost a drought, and it was an excess year. So,
yeah, this is from Gavarika's paper. I can tell you, Gavarika, an old man like me, was upset that people were criticizing it. So this is correct sign. You can read it. Okay, it's a anger against young people who are challenging you. So I don't know how much of it is true, but I just want to point out that by purely by luck, he got almost the right answer for no possible reason. Okay, because you are lucky, a period of 10 years, monsoon is normal, even without any forecast, climatology will tell you are right. So this is a paper from Current Science. You can look at it. About 2002. Why do you do that? Because 2002 monsoon prediction was wrong. Okay, by this model, and that's when IMD woke up. We had a big meeting here. I don't know whether I said big discussion about that year because July had the worst rainfall ever, 50% below normal. Okay, June was above normal, so it was absolutely unusual year. But even today, we don't understand why it happened after 25 years. So that's a positive result. Okay, now last year I did very well, which I presented in the last week of September. This year it will not be that easy. So when monsoon is normal, most of it come out. But one thing worried about IMD, here they give you a range. Here they give you one side, which I don't like. Giving one side is not right. You are trying to play it safe. You have to give a range. So any model, dynamic and statistical, has a range of accuracy. So I don't know why they're giving it. Have you any idea why? You ask somebody. It is not correct to do that. You give a number, you give an error bar, plus or minus. But they were right. Look at this. If they had given a range, they would have been wrong. Since they are given only above, they are right. So to me, this is not right. This is make it simple. Okay. In April, they made a prediction that 66% of the time it will be below normal. Okay. And only 33 and almost no chance of being above normal. And this is the normal distribution, 33, 33, 33, local terrestrial distribution. So it is highly skewed towards the drought, quite clearly. Okay. Now, within 1 month, they change it further. Now they're saying 84% chance that it is below normal. Now, it's not surprising because going by what Arindam has said and going by all the past, quite clearly, the chances that this amount will be below normal is more than 90%. So you don't need a water for it. You just can go past that. Okay. So let's watch this prediction and let's see what happens. Now, the other people who predict, of course, are Skynet. And anyway, these are detailed forecasts which are discussed at the end of the monsoon. These are more detailed forecasts, which is more challenging. Let's see how they get it right. See, this one, you can get it right for the wrong reason. It's average of whole India. So sometimes others can stop. But if you get this right, that is tough. Now, this is the June prediction, which I think they'll go wrong. They 8% will go normal, and unless something unusual happens, a lot of percent disturbance cover something, I think June will not well below 8%. So we'll see in the next 1 month what will happen. Now, let's see some forecasts from ENSO over here. They're also showing more like 4 or 5 mm per day lower, which is very, very high. I want you to remember that mean rainfall is 5 mm per day. They have 5 mm than normal. They are getting 2 mm of rainfall, which is absolutely shocking because evaporation is 2 mm. That means you're not getting any net gain of moisture in India. That's very serious. Okay. Now, this is how they are projecting. I think they are going to show higher production in June, more in July, more in August. September, I think, will come the next prediction. Okay, but the point about this drought is, although we have a drought, we still have extreme rainfall events. And I remember that work on that. So in a drought year, you now have very high rainfall events in very small regions. So that's still possible. Okay. Just because you have a drought year doesn't mean there are no floods. There will be floods in some small regions. Now, this is Skynet. Skynet is a very interesting company. It has no real model of its own. Right? Depending on the website sources that you all put out. So there are no real knowledge. So they are saying 70% below normal. Okay. And let's see what else is there. Yeah, they are 94%. They are putting a value which is close to what IMD also said. 92 at the IMDs. Okay, they're also giving distribution month by. We'll watch this later. We'll look at these predictions month by month, how they get it right. Now, here is Arindam's prediction. Again, his details are not given. You told him what the details are. So, in this picture, Arindam's prediction is a distribution, which is the correct way to do it. And it's comparing with the IMD forecast, which is here. His mean is here. And I don't know what is, sorry, this is different years. This 2021, let's look at this year. So this year, Adinam is showing about 4%, right? Compared to 8% of IMD. So we'll keep that in mind. We'll discuss that in the last week of the monsoon. Now, we all know that Suman Nigam makes very interesting prediction based only on the assisted data of the last 100 years. Okay? And we have seen the last few years that is forecast is quite good. Okay? Now, this to me is very interesting because we are going into a situation where people are going to use more and more AML. This is, think of an AML, using a large amount of past data to predict the future without any understanding about why it is happening. Okay? These predictions are quite good, but we don't know why. Now, this year he predicts very low rainfall in Kerala, South India, here, and he has given all India is 88%, so below IMD. Okay, and he has given. So I'm going to compare all these in the last monsoon because today we have a good way covering IMD and Suman Nigam, and so far Suman Nigam has done well. And to me, this shows there is some information in the past SST data pattern. Okay, so he is able to get the information out, but I'm unhappy about it. We don't understand why. Okay, so this is a challenge all of you are going to face in the next 50 years. Because more and more AM will be used, we will make all kinds of tall claims, but we don't know what is the mechanism. So that to me is very worrying that we depend on a system which uses a lot of data and computing power, but you don't know why it's having this action. So this is a challenge we are going to face in the next 50 years. Okay? Now, I'm comparing the last year's forecast, where he came out quite good here, but he was not so good over Kerala. Okay? Kerala is orographic rain, so your wind direction becomes very important, but it was okay over Mumbai. Okay? Had a good job. So his forecast is looking very believable. And he also makes SST predictions. Now we can look at it. We're showing a large SST anomaly in North Pacific, okay? In summer and later. This is not allowed to but look at this point. According to him in summer, 3.4 is not very important. It is closer to the coast. Okay? And only in winter, it is October, November, December, and so on, it comes to this. So this is very interesting. If El Nino this year is not a Central Pacific El Nino, then Indian Ocean is not affected that much. Okay? So how this moves is very critical. This is a statistical model. We don't know how well it does. Okay, let's look at the ensemble forecast from ECMWF. Now, this is starting with March. In March itself, they show that July is below now. Okay? Well below now. As you go along, you'll see it's getting worse. March, this is April. April shows June to be well below normal. That's going to happen. I think this is what we talk about at the end of this month. July, but September is close now. That's surprising. This is April. Let's see what happens next. May suddenly, this bothers me. The model is so sensitive to the initial stage. This is not a good news. Okay? So on May 1st, you said this is the normal. In June 1st, you are saying well below normal. Okay? So we'll watch this prediction for July also. Now let's look at a few other cases. This is multi-system forecast. And yes, it's showing Indonesia, India, and also Atlantic ITCs are all being below normal. And also the Indian Ocean ITCs are okay. So this is one forecast. You keep looking at it, because this gives a big picture, not just India. Now, this next one also very similar. This is Bureau Meteorology of Australia. This is CMCC. This Canadian model, Canadian model also shows similar structure. Then you have German model. I hope Germans are right because drought is less. And this is even more promising. That is this Canada, this Canada model, it also shows this one. But we have seen before, Indian model is not that good over India. Their model is focused towards Canada, the snow management, snow cover, and so on. So I'm not so sure, but I hope they are right. But look at them. They say Indonesia will know monsoon, but not India. So this is what understanding why different models showing different response. And this is Japanese model, very similar to other models. And this is UK metropolis, again, not showing very large reduction. Okay. So all of them show drought, but the severity of the drought is not the same. And this is beauty of bronze, not as bad as other, but still low. And this is ENSO, which is closer to what I'm sure IMD uses. And this is multi-systems forecast combining many models. Now that's good news here. Okay? So if you combine all the models, it's not so clear that the drought will be so bad. Okay? So that is they say that is a variability among models. And this is I think I'm fitting it. Okay, this is WMO forecast. This is again average of many models. So again, you see this and this here. And I'm really impressed by what happened at Atlantic. Atlantic IISc also becomes very big. Okay, now let's look at the next 10-day forecast. Unfortunately, IMD website has some problem. I'm unable to get my favorite data on the All India monsoon rainfall. Maybe Ravi can help me. I wrote a couple of emails. They are showing 10-day forecast for November 2025. I don't know who does, why you made the mistake. So somebody has to correct it, some mistake in the website. But anyway, ENSO development is doing a good job. So they are predicting increase, which has happened. But no, but then this is the good news. If this comes out right, things are going to get better because going up to 7 millimeters per day in June, which is not bad. So this we'll watch. But this is based on 30th May. I downloaded one of the latest one. Unfortunately, it goes down. Okay. So what was showing very high now. So this is what worries me. Very sensitive to wind condition. That is not a good news. That shows that either the assimilation of moisture, there is a problem, or the model has a dry bias, and assimilate actual observation of moisture, it changes. It's possible. Okay, they also give this I like. I will compare them next week with all the subdivisions of rainfall. This is a good result which I would like to use next year. Okay. Now this is again from ECMWF. This is the first week of June. You can see that they are saying onset will occur this week. So I hope they are right. But the next week, not so good. Week after also not so good. Okay. So the monsoon doesn't progress to North India. Okay. And this is the last week of June. So you go by this, I think June is not going to be a very good month. Okay. Now let's look at comparison between, we always do that here, GFS and very interesting difference in South India. This is based on 2nd June, next 14 days. This showing more rainfall over South India than otherwise. In North India, there's some western disturbance issue here coming in. Let us see what happens next. And this is a one called the Bharat forecast system with Bharat Subhadhyay of recorded. And this will predict district-wide rainfall. So I'll also compare this next few weeks. If you see here, it shows that this is for 4th June, tomorrow. Good rainfall over Kerala, but somewhat weakening here, and the system going over to Maharashtra in the next week. Okay, let's see whether that's true or not. Okay, I think I've taken a long time, so I will stop here. And I want to add a new thing they are doing, which we'll discuss more next week. They are trying to predict rainfall at 1 kilometer resolution over Uttar Pradesh. I'm puzzled. I don't think the models are good enough to do that, in my opinion. But they're claiming that they're going to sort of use a lot of rainfall data from the ground initialized, and they're going to use AM, and that's what they claim. The details are not clear. Ravi is trying to find out. If you want something more, I'll talk about it in this season. Okay, thank you. Very question. Now, who will project next week is Chetan Majalia, one of our students. No, I get it. He will talk next week. Okay. Any questions?
Yes. Now, back to the relationship between El Nino and yeah, when El Nino let's say, Indian also predict. Because the Sinka says that Indian also affects the
Yeah.
That
That is only